diving at Blue Heron Bridge, and one of the things that we see here are sea stars, or starfish, they used to call them. And starfish are kind of interesting because
they regurgitate their stomachs.
That's right. And why do they do that?
To eat.
That's right. Very good.
Yes, my nephew is right. I don't know where he picked it up. I did not teach it to him, but we're going to use the starfish as a means to talk about enzymes. Some starfish do invert their stomachs out of their mouths and then release digestive enzymes to absorb the nutrients of their food. So what is an enzyme? That's what we're actually talking about. What is an enzyme? An enzyme is a protein that has a 3D shape that allows it to catalyze this reaction. That means it speeds it up, makes it more likely to happen. The way it does this is it lowers the activation energy. I want you to understand that enzymes are not the product, the thing that's being made by a chemical reaction, or the reactants, the things that are going to react. Instead, an enzyme is a helper molecule that makes those reactions go faster. Every enzyme has a special shape, and if you change it away from its natural shape, we say that you are denaturing it, and that makes the enzyme stop working. Heat can denature an enzyme. Anytime you get more basic, you change the shape of the enzyme, and the enzyme doesn't work anymore because it's denatured. Anytime you get more acidic, you change the shape of the enzyme doesn't work anymore because it's denatured. Anytime you get the enzyme too hot, the enzyme vibrates until you break the hydrogen bonds, changes the 3D shape, doesn't work anymore. Any of those three will denature an enzyme. If the enzyme gets cold, it'll also reduce the activity, but not because hydrogen bonds are breaking. It will reduce the activity because you're slowing down the interactions between the substrates, that's the things the enzyme works on, and the enzyme itself. If the solution is cold enough, you're never going to have an enzyme and a substrate touch each other, and then you're never going to have a reaction. In the case of breaking down food, they'll take a molecule and they'll stress it, which makes it more likely that it would break. It could break down on its own, but the enzyme, by lowering the energy it takes to break it, the enzyme does something and that lowers the amount of extra energy to break it, the reaction is going to go faster. Or an enzyme might act like a little machine. It'll take A, it'll take B. They could stick together on their own, but it'll take A, it'll take B, it'll bring together at the right speed and the right orientation. They stick, it lets go. It picks up another A, it picks up another B, it sticks them together, it lets it go, picks up an A, picks up a B, sticks them together, it lets it go. In that case, the enzyme is like a little machine. It goes over and over and over again. But regardless, understand, the enzyme is not used up in the reaction. The enzyme can repeat over and over and over again what it's doing. Whether it's combining things or whether it's stressing bonds so they break more easily, the enzyme is like a little protein, the enzyme is like a little machine made out of protein that can make the reaction go faster by lowering its activation.
That's okay. I've been bitten. Ow, he has teeth. Ow, ow, ow. Somebody...